All right, so in any problem like this, the first thing that you want to do is factor when possible. And with that change to the numerator, this is possible to factor this. So I am going to look to factor what multiplies to negative 12 and adds to negative 4. So that's going to give me a negative 6 and a positive 2. So I'm going to write the top as x minus 6, x plus 2. And the bottom doesn't factor, so I'll just leave that as an x minus 5. Right from here, before even looking to see if things cancel out, I want to do my domain restrictions, because even if they cancel out, there's still a restriction. Anything in the denominator is going to make a restriction. So x cannot be 5. If x is positive 5, then the bottom's going to become 0, which will then give us an error because we can't divide by 0. So my domain is going to be everything with the exception of 5. After I check for domain restrictions, I would then check for what's called a hole. Does anything cancel out? If something matches top and bottom as a factor, that's called a hole. And I don't have that here, so I'm going to just write NA. Is there a spot for hole? Okay, well then there's no spot for hole. Okay, so there's no hole. After I do the hole, I do what's called the vertical asymptote. If something cancels out, it's not a vertical asymptote. But in this case, nothing canceled out. So my vertical asymptote is going to come from that restriction. I'm going to take that denominator and set it equal to 0. A vertical asymptote is an x equals equation. And what it looks like on the graph is a vertical line going through that value. It essentially breaks the graph into two regions, left and right, which is why my domain is what it is. I'm going to have something happening on the left-hand side of that line, negative infinity to 5, and something happening on the right side of that line, 5 to infinity. From here, the next step that I would do is look at the horizontal asymptote in the slant. You have one or the other. You can't have both. And that's going to come from the powers in the problem. So in this problem, I've got an x squared over an x. Okay, and that would reduce to just an x on the top. And an equation that's just x is a slanted line. It's a linear line. So this is a slant. There is not a horizontal asymptote. Horizontal asymptote would be like an x squared over an x squared, or an x over an x squared, like having those flipped. This one is what a slant looks like when the higher power is on the top. When you're finding a slant, you're going to do the opposite of the bottom and the coefficients of the numerator. 1, negative 4, and I'm not even going to use the negative 12 because that's going to give me a remainder. I don't need the remainder. So I end up with 1 and 1, which is a slant of 1x, or x plus 1. What that looks like on my paper is a y-intercept of 1 and a graph that increases at a constant slope. If you remember from your test, some of you lost points because you did not graph these things. I'm looking for you to be able to find them, but also to show me what they look like on the graph. So I want you to be able to get that slant to the paper. After I do slant, I go to end behavior. If my slant is, or sorry, if my horizontal asymptote is 5, my end behavior is 5. But my horizontal asymptote doesn't exist. I have a slant. So when you're working with a slant, your end behavior is the infinities. This part of the graph here would continue to go down if I extended the pattern, which makes the left end behavior negative infinity. This part of the graph up here would continue to go up if I continued that pattern, which makes the right-hand side of the graph positive infinity. Those infinities would change if the slanted line slants the other way. If it has a negative slope, then your infinities would be different. All right, from here we learned some new vocabulary words, or at least practice with new vocabulary words, x-intercept and y-intercept. The x-intercept comes from setting the numerators equal to 0. So x minus 6 equal to 0 and x plus 2 equal to 0. Another way that we learn how to do this is we typed it in the calculator, and you can trace the 0 on the graph. Okay, so I have two of these, 6, 0, and negative 2, 0. And what they look like is just points on the graph. 6, 0, and negative 2, 0. The y-intercept, you can either go to the table and look next to 0, or you can plug 0 in for all of the x's. You can do this in the original version or the factored version. I end up with 12 over 5. Negative 12 over negative 5. Or 2 2/5. Okay, so 0, 12/5. So it's a little bit above 2. I'm going to make a point here. So x and y intercepts are points. You can see them in blue here. All of the other pieces of this graph are going to come from actually looking at the graph. So take a moment, type the equation in the calculator, hit graph. I already know what this one's going to look like just based off what I've got going on here. So I know it needs to go through these points. And it kind of just, once it hits that, it goes like that. And then over here, looks like that. I'm not expecting you to know that. Type it in your calculator, hit graph, get the image. From here, I can see that there's no U shape, right? I'm not seeing a U or an upside down U. So in terms of mins and maxes, I'm going to write NA. And if there's no mins and maxes, what else do you know? There's a word up here we haven't talked about in a while. Unbounded. There's not boundedness either, right? You would need an absolute min or an absolute max to have boundedness. And I don't have either of those, so not bounded connects with that. What about continuity? Is this graph continuous? We haven't talked about that word since the unit before.
It's not at the vertical asymptote.
It's not, so I'm actually going to write this in red because it's connected to that vertical asymptote. So it's discontinuous at x equals 5. That break is causing it to separate. All right, so there's this blank for end behavior that you're not writing anything in. So what do we've got left? We've got range, increasing, and decreasing. So when I'm looking at increasing and decreasing here, think about starting at this part of the black line. This graph is going up. So this is an increasing interval. And if you start at this part of the black line, this part's going up too. So I have two increasing intervals. Does anybody remember what part of these intervals do I use when I'm writing increasing, decreasing?
Yes.
What is it?
The
The x values. Specifically, like which parentheses would I use? If I'm using x.
Brackets, right? It's a section, right?
You can use brackets. What I mean is, so I should rephrase the question. Which of these categories, the domain, right? I'm going to use the domain numbers. And if you use brackets or parentheses, it doesn't matter for increasing, decreasing. So I'm going to use these two. Both of those intervals are increasing here. So negative infinity to 5, 5 to infinity. There are no decreasing intervals on this. And then looking at this graph for the range is like looking at it from the bottom to the top. There's graph down here, that's black. And as I go up, I'm still seeing graph. I'm still seeing graph. I'm still seeing graph. I see this black graph all the way from top to bottom. So my range, negative infinity to positive infinity. I might have a stop in the range if I have a min or a max, if I have a horizontal asymptote, if I have a hole. I don't have any of those.
So if you have none of those three things, it's like
And
100%
negative,
minus.
yep, negative infinity to infinity. And if you have one of those things, it could be negative infinity to infinity. You just have to consider those things. But if I don't have them, then it's definitely that. All right, let's look at the next one. So factor the top. I'm going to divide out of 3x. Factor the bottom. Perfect square, so plus 5 minus 5. My restrictions, -5, and +5. Coming from that denominator. There are no holes here, nothing cancels out. So then my vertical asymptotes must be the -5 and +5. So this graph is broken up into 3 intervals rather than 2. Horizontal asymptotes, actually, continuity. Is it going to be continuous? If I've got those vertical asymptotes breaking it up, it's going to be discontinuous at -5 and 5. You can wait to do that later, but it does all connect to each other because that's causing that break in the graph. All right, horizontal asymptote. The x squareds cancel out and leave me with a y equals 3, which means I don't have a slant. So my end behavior is my 3's. Oh, I wrote discontinuous in the boundedness spot. All right, so x and y intercepts. X-intercepts, set the numerator equal to 0. We're going to have 2 of them. 3x is equal to 0, and x plus 2 is equal to 0. My intercepts are going to be at the zeros. And at -2. So something's happening in there. My y-intercept, I'm plugging 0 in. 3 times 0 squared plus 6 times 0 over 0 squared minus 25. 0 over -25 is giving me another 0, which I've already plotted. So at this point, I want to see what this looks like in the calculator. Make sure when you're typing it in your calculator, you're using alpha y equals. So I've got these 2 like reciprocal even looking things on the left and right, and then this U shape in the middle. So I want to sketch that. And I know this U shape's going to have to go through those 2 points. So something like that. Which means I do have a maximum. I'm going to call this a local maximum because it's not the highest point of the graph. There's graph above it, right? So did anybody trace that? See if you can. What is it? All right, so we've got no min. This is going to affect our increasing and decreasing because this interval here is an increase, which if I'm looking at my domain, this is my -infinity to -5. But the middle interval, -5 to 5, is 2 different things. So we have to break that up. We've got an increase on this side, but a decrease on this side. And we've got to break that up at that x value, which is -1.04. So I've got -5 to -1.04 and -1.04 to +5. I'm splitting up that -5, +5 interval. This is a decrease as well, which is that last interval of my domain, 5 to infinity. Now, is this graph bounded? It's got a maximum. Is it bounded? Can you get above this point on the graph? Is there black line above this point? Yes. So it's not bounded above. It would be bounded above if this part of the graph didn't exist and it was just an upside down U. Right? This is the highest point on the graph. It's bounded above. If you have a lowest point on the graph, it's bounded below. This one is going to be unbounded. All right, so let's see, what does that leave us with? This isn't a blank. We talked about it being discontinuous at x equals -5 and 5. So now I'm only looking at the range. So starting at the bottom of the graph, I've got grid, I've got black. And I continue to have black until right here, right? This portion of the graph is that U shape. So this is -infinity to the maximum, but since it's the range, it's the y value of the maximum. So the first part of my range would be -infinity to 0.13. And then nothing's happening in here. There's no grid. All of this is blank. So I'm not going to put anything there. I'm going to call that my U. That's my break. And then it picks up again right here, and that's at this green line, which is 3, and goes off all the way up to infinity. What do you guys think? Remember that? I feel like we kind of just did it. So instead of doing full analysis for every problem, that's not what you're going to do on your midterm. Your midterm's multiple choice majority, so you're just going to do pieces of it. It's going to give you an equation and say, what's the horizontal asymptote? A, B, C, D. What's the whole? A, B, C, D. So instead of making you do full analysis for 15 problems, when you don't need that, I have 9 problems around the room, and it's just specific parts of the problem. So you're not doing a full analysis every time. You don't need to use the graphs that are in your packet. Like, you don't need to physically graph it for multiple choice. You can if it helps you, but there are graphs in the packet if it helps you. That being said, number 7 has a scale of 1, and that's not going to work. So if you're using the graphs to help you, I need you to change the scale of number 7 to 2. So this is on page 9 through 13, which seems like a lot, but that's because I provided a graph for every single one of them that you don't necessarily need. Okay, but on 9 through 13, number 7's scale would need to be 2 if you wanted to use the graph. So just kind of make mental note of that. I think I have on number 7, change the y max to 20. So like there's that hint there, which is why the graph needs to go up to that. So just like yesterday, I want to give you time to self-pace through these 9 problems. It's just picking apart specific vocabulary words, making sure you're okay with them. You don't need to use the graphs if you don't want to. The answer key is below the problem. The problem is in front of you. You don't necessarily need to get up until you're checking the answers. All right? Anchor would be the test review guide. The actual test review guide is 14 through 21, which again seems like a lot, but that's because these graphs take up like half the paper. All right, the key for that's on campus. If anybody wants me to sit with you and work through any problems, again, this desk is available. Come up and join me at any time. You can work together too. All right? Yes, yep. So I think, is it only one blank?
Yeah.
I think I wrote above it the word local or absolute when I did it. Do you know what I mean? Since you can't necessarily circle it. Okay, so say you solve the whole problem and you get x equals 2 and x equals 5. Those are your final answers. You factored, you solved. If either of those is a restriction from the denominator, in the original product, you know how you get a fraction in the beginning? You can get those denominators. If the restriction matches your answer, it's called extraneous. That's extraneous, yes. Yep. Mhm. You type it in? Alright, what are we looking to find? Mins and maxes. Alright, so you're gonna have to trace them all. So do a second trace. I guess whichever one you want, I start by min and then just kind of work my way over. Now that min is considered a local, right? Because that min is lower, right? So I'd write like local, because we can't really circle it, because there's also an absolute. So maybe you just write like local and then write that coordinate point of that one. It doesn't matter. Alright, and then just keep going. Now trace that max. Now is that considered local or absolute? It's local. So for that, I think there's only one max. So you could circle local for that one. And then you got one more to trace after that. And that one I'd write absolute with, since that is the lowest point on the graph. Yeah, that's fine. Now boundedness is basically saying, do you have a highest point of the graph? If you have a highest point of the graph, you've got a bounded line. Do you have a lowest point of the graph? Below, so you're bounded this way below. If you don't have a highest or lowest point of the graph, it just wouldn't be bounded. It's all about bounded.
What does it mean if it's bounded above and below? There's a highest point and a lowest
So
point.
like a sine graph looks like that, so it kind of just keeps fluctuating back and forth. So like there's a min, an absolute min, and an absolute max. One of the graphs we saw looked like this. It was like asymptotes kind of.
That would be above and below.
That's above.
Because this is like
Yes.
the highest, but there's
And
also
then this is
like
kind of the lowest in terms of it. Now, in terms of your graph, we've got negative 0.9. What does that say? Negative 7.2. So let's say like here-ish. And then you've got 0.7 and negative 0.6.
I only know that.
And then 2.4 and was that negative?
negative.
So So just to kind of get like this general sketch, so we can use this. Doesn't really matter about anything else, right? The reason I'm just sketching that, you don't have to, it's just because when you're talking increasing, decreasing, it kind of helps to physically see it. So from here, if I'm starting here, I'm decreasing. So this interval from here to here is a decreasing interval.
And that would be true if there's negative 0 point.
Yeah, so this is considered like negative infinity, and then you're going to this x value.
So negative 0 point.
Yes.
And then
And then from here to here,
negative 0 point
9 to whatever this was.
or that would have the y.
The point, you're gonna use the y, or x value,
Right
so the
now, so
0.7.
0
And
point 7.
that's increasing, right? And then the 0.72, which is the top, now it's going down.
2.1 or
Yup, and that's a decrease, right?
wait, why would that not call these negative 2.1?
Because I came over for the x and went down for the y.
So this would be negative 8.4.
You're using the x value,
So 2.4.
the 0.72 to the 2.4. And then finally, the 2.4 forever, and then it increases, yeah. So that one's tricky in terms of that. Easy enough, take it?
Yeah.
Alright, you got those, is it checked, you wanna check it?
Sure.
One is good, yep, alright, it goes in. What are we looking to do?
Let's go
So
on.
main continuity of, okay.
Because of the vertical asymptote for this, would that just be like 2/3?
Correct.
Yeah.
And that would be, like, it's,
So it's a number over x, like x is in the bottom.
so, 1,
So we're talking about, are you talking about a horizontal
Yeah.
asymptote? No, no. So anytime you have an x left in the bottom, that's a 0 asymptote.
so,
If you're not sure, you can pick that, you don't have to do that. You pick graph, you'll see it leveling off at 0. See how it's like getting close to the x-axis. So if you have x left in the top, it's a sign. If you have x left in the bottom, it's a 0. If you have no x's left, it's a number.
does it just be y equals 0?
Yep.
And this is 0.
Mm-hmm.
And it's just continuous, would that be at the 2/3?
Uh-huh. See how it splits up at that point?
Mm-hmm.
You're gonna split this up at the x value of 2/3. Do you get what I mean?
Yeah.
So this would be negative infinity to 2/3, and then 2/3 to 0, and wait, no, that's 0.
Just 2/3 of
Just
infinity. There's
2/3
just
of
two
infinity.
regions.
So like that.
Exactly.
And do we have to go with it?
No, that's just there if you need it. It helps with range sometimes, but you won't even have range
Yeah.
discussion, so I just put it there, you don't need it. Increasing, decreasing, sometimes it helps to see it, but you have it in your calculator too, so you have to. You just look it up this way.
So this is,
Without bounded.
this would be bounded above and
As
below.
long as that's below, yeah.
And there'd be no, like, no middle, it's just a,
Correct. No, no. So do you see why that's above and below? What she was
Because it's
saying?
above here,
It's look, you
above
can't
the
get below
X.
that asymptote.
and this would be an absolute max.
I
Since
agree,
it's
yeah.
above. there's 0.
Yeah, we call that like 0 with all this.
Would this just be like negative infinity to this and that to positive?
Yeah, but the x value.
Yeah.
And then you just have to figure out which side's increasing, which side's decreasing. We call this when there's an e negative 7. It's just 0.
Okay.
Then the e negative 7 means point 0, 0, 0, 0, 0, 0, 7 zeros.
So like that.
And then a 6, so it's essentially 0. Increasing. Yeah.
So it's like I would use the x for this and that.
Yes. Yes, and I'm sure the y is going to be like a distractor.
Is this on one or?
I'm gonna, I have it ready for you, and then once you finish it, you'll just put your letters on mine. You know what I mean? It just came in right then.
The thing we did yesterday, is there more practice on that?
Yes, so did you do go to page 14 yet?
Yeah. No.
So-
Would this be what we did?
Let me,
This just looks like more.
okay, then that's not what I need.
Because I feel like I'm better with the graph. I just wanna do something.
What is it?
Page 557. Because I also, we have multiple other classes, so.
You're right, yes, yes. Go to page 6 and 7. 5 is more just
Oh, 5 is
factoring.
factoring,
Yeah, 5 is just factoring, but yes, that's what you want. And the key for that's on Canvas.